Hi there. I'm going to show you how we're going to take an activity in Brightspace and we're going to actually complete it in the EquatIO Mathspace environment. So here is our Brightspace environment, so our D2L, and there is an activity here that was done in a previous video where we've updated it so that students can complete this using EquatIO Mathspace. Great. So the next step would be, well, how would the students do it from there? How easy is it going to be? Okay, well, here we are. We have the question, and this is going to be a scatter plot that we're going to be graphing, and we're going to find a line of best fit. But they are actually asking us first to find the mean coordinate, meaning we need to find the mean of our x values and our y values, our dependent and independent values. So what we're going to do is we're going to go x mean, and then so I've started this off, and I'm going to start listing out all the numbers just quickly for the hours worked, and start adding them up. Now, please keep in mind as I'm typing this is not a calculator. EquatIO is not going to do the work for you. Students have to show that they can do the work themselves. Now, I'm going to divide that by the number of terms, and there's 9 terms. I'm highlighting the whole top to indicate that's going to be my numerator. Then I'm going to do a slash. So I do the slash, and now all of a sudden I'm able to put in 9 as my denominator. Now, just for real estate purposes, I'm going to keep moving horizontally here, and we're going to add up those values. Now, if we want to add up the values using a calculator, whether it's on your phone or a separate calculator, or however you want to do it, that's great. What I do have to mention, up above here as an extension is EquatIO, which has a scientific calculator. So it's very handy to have on the fly. So I'm just going to show you that, and I'm going to bring this over here, and I can actually go to the bottom right hand corner here and make this a little smaller so it's not taking up so much space. And I can just quickly start typing these in. So we can just start finding out our sums. So 4 plus 10 plus 8 and so on and so on. And then we can find out what the sum is of our numerator. Okay, so we have 135. So if that's going to be, and I'm just going to confirm 1, 2, 3, 4, 5, 6. Oh, and look at that. I made a mistake up here, as you can see. I knew there was something off there. So there we go, 63. I love how it automatically adjusted right there. Fantastic. So 63 it is, and we are going to divide that by 9. And of course, if students didn't know the answer of that already, they could use the calculator to take that next step. So 63 divided by 9. And we do know, however, that is 7. I'm going to go to hit enter and do a new line. So I'm going to go Y, and I'm going to write the word mean again. If you'll notice, so that's a subscript. So I can start typing in subscript and highlight that, and then I'll go down below. But another shortcut for subscript is just doing underscore. Mean, and then just press the right arrow, press equals, and then I'm just going to repeat the process from before, but this time with our other values here for our y values. So 12 plus 35 and so on. And what I'm thinking is it would be really cool if I could just copy and paste this into my calculator on the right when I'm done. And I haven't actually tried that before, but I'm thinking out loud as we're recording here and hoping, oops, this is what happens when I don't highlight everything first and then divide by 9. So divide by 9 equals. So I'm going to try something here. Again, as I'm live here recording, I have no idea if this is going to work. Let's see. Oh, sweet. All right, look at that. So we have 179 as my sum. So 179 divide by 9 again, of course, because the number of terms has not changed. We have 9 items. And then what we could do in this case, maybe not as simple as the last one. So I wonder, there should be an answer key. Here it is. Answer is going to take my last answer, which is the 179. Divide by 9. And we have 19.8 repeating. So I'm just going to round to 1 decimal place, and we're going to go 19.9. Excellent. Okay, so we have now found our mean coordinate. So I'm going to type that out just really quickly, mean coordinate. And we're going to go down to a new line right here, and I'm going to type out my mean coordinate being, of course, our x value, which was 7, and our y value being 19.9. Now I'd like to do the graphing part. Okay, so the scientific calculator, we don't need this anymore. Done. What we're going to do, however, we need to plot these points and get the scatter plot. So this means we're going to bring up another tool. Okay, graph editor. This is actually using Desmos. So let's open this up. Bring this down. And here's what's really nice about this is that I can click on this plus sign. Okay, and table. I can just start listing my pairs. So I'm just going to go down for the X. And for my Y. What I could also be thinking now is, where are these points going to be on my graph? So I don't need this table here anymore, so I'm going to bring this up. Have a little more real estate. And looking at this, it's like, okay, well, taking a look at my X and Y values, I need to make some changes on my coordinate grid here. So I'm going to click on the wrench. Let's make some changes where I don't need really any negative. I don't actually have any negative values for my X. So I'm going to leave it to, let's say, -5. I'm only doing that just to have a little bit of space on the left of the actual y-axis. And my x-axis is going to go a little higher. Let's say it's 10, but I'm going to put 15. Okay, for our y, we're not going into the negatives here, but I am going to just do it again, just giving you a little bit of a buffer of -5. I may even change that still. And a high, let's say as high as 35. Let's go to 40. There we go. And while I'm here, I'm going to label this. So I'm going to be very clear that here for my x-axis is supposed to indicate, and I'm just going to look down again, just a quick little reminder, hours worked. So let's do that. Hours worked. And my y-axis is number of baskets of peaches picked. And I can see it actually populating here on the left, which is nice. Okay, very nice. And I could, of course, change the step so to be whatever I want, to going up by whatever I want, but I'm going to leave it the way it is. It looks pretty nice. All right, so there's my scatter plot. Now, what I'd like to do is graph that mean coordinate that we had of 7 and 19.8. So if you just recall that, so right here, if I just move this out of the way for a moment. Right, sorry, I didn't actually insert this math, so I'm going to insert that now. It's nice that I didn't lose it just because I didn't click on the equation editor. Now I'm going to go back to my graph, and I know I didn't lose my graph either. Same idea, which I love. I'm just going to click on that, and it should just give it back to exactly what I was just doing, which is fantastic. 17 and 19.9 is my ordered pair here, my mean ordered pair. So I'm actually going to include a new table, and my X being 7 and 19.9. And yes, it's green, it's right here. It's a bit thicker than the other ones, but I'm actually going to even try even a little bit better and do a different color. So I'm going to hold down my cursor on the green, and now I'm just going to choose red. Okay, so we can see that point. Hopefully now when we do our line, and it looks like here, okay, there must have been something there. That's okay. And I'm going to go to 3. I want to do my line of best fit. So the way it works in Desmos is that we're going to graph our line. See how it automatically did x to the sub 1 here, y to the sub 1. We're going to now do our equation of the line. So y equals mx plus b, but we're going to do it specifically for those points that were above. So we're going to go y, and we're going to go sub 1. So sub 1 here, oops. If I actually just type the number 1, it automatically goes to sub 1. And then normally you go y equals mx plus b when you're drawing a graph, like creating a graph for a line, but I'm actually not going to use the equal sign. I'm going to use the tilde sign. And you have to look on your keyboard for mine is the far left. And this is going to be that approximate piece because we're doing our best line of fit here, an approximate line. And mx, 1 again, plus b. Excellent. And yay, it goes through our mean ordered pair, which is exactly what we were hoping for. Looks like a really nice line of best fit here. We get some really good information here as well. So we're looking at our regression. So this is talking about how best is our line fitting our dots, which is fantastic. And here we have actually more information as well, is the actual slope or rate of change of our line and our y-intercept. So great data to have. There's our line of best fit. We've done the work. Now we're going to insert this graph. Okay, so let's insert graph. Top left-hand corner. This is what normally happens here. Let's get rid of this guy. Oh, we don't need this anymore, so I'm just going to click on the EquatIO. And there we go. A little more space. There's our line, our scatter plot. There's our line of best fit. And now the student can answer the rest of the question. A farmer is trying to find out what the average rate of picking peaches is for the workers in his orchard. And that average rate, which would be the slope, the m that we found there, and they can go back to the graph, is pull this back up here for that information, and they can see it in this line right here. Okay, so I'll leave that to the student with their therefore statement, therefore the average, blah, blah, blah. And, but basically, I think the main thing is that you see here is how can we use EquatIO in this really great, simple way to answer these questions that are in our Brightspace environment, hand this back into the teacher when ready, and then the teacher can then provide the feedback, and they can actually see the steps the child did to answer the question.